Hi, I'm Mia, and today I'm going to show you some examples of medical imaging workflows on the Aridhia digital research environment. The Digital Research Environment, or DRE, is a powerful platform with fair data services and analytical workspaces. Together, they facilitate collaborative research, data sharing, and advanced analytics for clinical and life sciences research. Workspaces are secure sandbox environments where research teams can collaborate in real time and work with diverse data such as clinical, EHR, genomic, imaging, and other relevant data types. Today we'll take a special focus on medical imaging. Within the workspace environment, researchers can natively explore and discover a repository of medical images and associated metadata. One common way to do this is through XNAT, a medical imaging platform that approved researchers can access from their workspace virtual machines. Data owners can specify who can view, edit, or analyze the data. They can also define automated access controls to govern researcher access and ensure that sensitive information is accessible only to authorized users. Fair data services and workspaces work together with audit trails that record who accessed the data, when, and for what purpose. This transparency enhances data governance for data owners and researchers alike. From XNAT, data owners can manage their datasets and configure project settings such as setting data anonymization rules to remove sensitive data before sharing it with researchers. This protects patient privacy while fostering research use. On XNAT, researchers can search across all available datasets, imaging types, or patients. Datasets are arranged in a hierarchy of projects, where researchers can view metadata, preview images, and access relevant information such as patient demographics, imaging protocols, and annotations. Researchers can search for specific imaging studies, filter by metadata, and generate reports on image and clinical data. XNAT's OHIF viewer integration also provides a valuable set of image annotation tools. Users can add annotations, perform measurements, draw contours and segmentations, and save the collection to their own private projects. Researchers can also use XNAT for high-performance computing and data processing. Users can connect to XNAT APIs for advanced analysis or download selected imaging sets to develop their own analysis and models. With Jupyter Labs connected to their workspace and imaging files, for example, researchers can develop scripts and notebooks in real time and share insights with each other. In this case, I'll pick a notebook with a predictive machine learning model that a colleague developed in our workspace. I can view the notebook code and results and continue to develop the model. Since my workspace has private access to a service called Git for Git version control, I can version and develop my code with team members to track changes over time. This helps preserve our team's project history and ensure reproducibility and scientific validity for the model we developed. Going into the workspace files, I can also see that my colleague has drafted a report about the model using R Markdown. I can use the RStudio app in my workspace to run this and generate a PDF report copy. Now that my PDF has been saved to the files, I can preview my final report. With the report ready and my notebook finalized, I can request a workspace airlock to export my results. This is an audited gateway where research outputs can be validated and approved for internal use or publication. This process is governed by the data access rules and controls in place for my workspace. For the purposes of this demo, I'll act as an administrator approver and authorize this request. Thanks for your time today, and please get in touch if you have questions or would like to learn more.